just to figure out what the graphs of the sine function and the cosine function look like. So we're going to start out with the graph of sine. We're going to eventually put our graph on this top XY axis, but before we do that, I want you to get your calculator out. You've found the sine of each of these values on the unit circle before, but I want you to quickly, with your calculator, go ahead and put it in radian mode and find the sine of each of these values. Fill in those values off to the side. So for example, if we're finding the sine of 0, you of course would use the ordered pair, 1, 0, and the sine is the y value. So at this location, the sine would equal 1. Go ahead and put sine of pi over 6 in your calculator. Make sure it's in radian mode. You should get 0.5. Continue going around the entire unit circle and find those sine values. Only sine, not cosine at this point. If you haven't already, pause the screen to find those. You can round to the tenths place. Once you've found all your sine values, remember we're only focusing on sine on this side of the notes, you should get the values that I put out to the side. Now, what I want you to notice is on this first and second quadrant, what sign does the sine value have? It's all positive. Just like we talked about last week, in the first and second quadrant, sine is positive. Then, when you get into the third quadrant, the sine values are all negative. Same within the fourth quadrant. Sine values are all negative. That characteristic is going to show up in our graph when we put it on the coordinate plane in just a second. When we put it on the coordinate plane, we're going to focus on these values. The sine of 0 is 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. We're going to start out by putting those on the coordinate plane. So I'm going to zoom out here. And let's label our x-axis. On our x-axis, let's put 0 to 2 pi. Right smack in between 0 and 2 pi, we have pi. Right in between 0 and pi, we have pi over 2. And between pi and 2 pi, you should have 3 pi over 2. Now you'll notice, using your little circle below, that the highest y value, the highest outcome that we could have was 1. The lowest was negative 1. So go ahead and label your y-axis with that. And now let's put some important points on this coordinate plane. We know that at 0, the sine was 0, so we have an ordered pair there. The sine of pi over 2, or 90, was 1. The sine of pi was 0. The sine of 3 pi over 2, or 270, if you look down at your unit circle down there, was negative 1. And the sine of 2 pi is the same as the sine of 0. It's back at 1. Now, this pattern, although we are just graphing in between 0 and 2 pi, will continue because the sine function is what we call a periodic function, meaning it keeps this, a period is one cycle of the graph, one shape of the graph, but it'll continue forever and ever in this manner. Now, as we left 0, if we look at the sine of 0, you'll notice down on your unit circle that it went from 0.5 to 0.7 to 0.9. So it's all approaching this 1 value. As it leaves and goes from pi over 2 to pi, so in between pi over 2 and pi, the numbers start decreasing again. So they go from 0.9 to 0.7 to 0.5. So we know that it would go down. And then after pi, it starts getting increasingly negative, getting closer and closer to negative 1. And then as it leaves negative 1, as it leaves 3 pi over 2 and gets back to 2 pi, it gets closer and closer to 0. This is one cycle or one period of the sine function. It will always have this basic shape. Now, as I said, it's a periodic function, so this would continue on to the left and to the right. So let's talk about the domain. and the range of this function. If this function continues forever to the left and forever to the right, the domain of the sine function is negative infinity to positive infinity. There's no x value that the graph cannot be. The range, however, is going to be stuck in between two y values. Take a look again at what the smallest y value was and what the largest y value was. We would say our range is in between -1 and 1, and because it hits those values, we would use brackets. The last thing I want you to notice is how on your graph, in between 0 and pi, so in between the first and this is the first quadrant, this is the second quadrant, notice how it's all positive. And then when it got into the third quadrant and the fourth quadrant with our x values, our y values were all negative. So it followed that same pattern that you saw below. By the way, we also will be using just a basic pattern recognition of a sine curve. Notice that this 0 value is at the center of the graph. So we say that the graph starts at the center, then the sine graph goes to its highest point, the top, then it goes back to the center at 0, where it's at pi, then it goes down to the bottom, and then it comes back to the center. That is the pattern that I will continually reference for sine functions as we graph more throughout the week. Let's try cosine on the back. In this next portion, our goal is to figure out what the graph of cosine looks like. So we will eventually get to this top graph and put the cosine curve on the x and y plane. But before we do that, we need to find out what each of those ordered pairs is going to be. So again, get your calculator out. You'll notice that these are all listed in radians. So turn your calculator into radian mode. And let's find the cosine of each of these individual values. So insert the cosine of 0, you should get 1. Insert the cosine of pi over 6, and keep going. You can round to the 10th place. Pause the screen and fill those out on your own so that you can start to recognize patterns that will make the cosine curve. Thanks for pausing the screen. Check your work after you've found out your cosine values for each of these unit circle angles. I want you to notice some patterns just like we did before. Notice in the first quadrant, all the cosine values are positive. The other quadrant where cosine's positive, fourth. Just like we learned about last week, all students take calculus. The C and the A are the two quadrants where the cosine will be positive. On the other hand, second quadrant, negative, third quadrant, negative. That pattern will show up on the graph. Just like we did with sine, we're going to put our key kind of quadrant angles on the graph. I just highlighted those in red. So let's go up to the top and put those key angles on to get our basic shape of our cosine function. We notice that we have 0, pi over 2, pi, 3 pi over 2, and 2 pi are our main x values. And then the highest y value that the cosine receives is 1. Lowest you should see is -1. Everything else is stuck between there. So let's go ahead and plot each of those points. The cosine at 0 down here we see is 1. The next key point or axis angle pi over 2 goes down to 0. At pi, we get to -1. At 270 or 3 pi over 2, we get back to 0. And then back at 2 pi, it's the same as the cosine of 0, which is 1. Now, in between there, as you leave the cosine of 0 and go up to pi over 2, you'll notice that it's 0.9, 0.7, 0.5. It gets smaller and smaller, closer to 0. Then, in the second quadrant, it goes negative. It goes -0.5, -0.7, -0.9, all the way until it gets to -1. Then, as it leaves pi and goes to 3 pi over 2, we get -0.9, -0.7, -0.5. It reaches 0. And then, in the fourth quadrant, it becomes positive again, reaching all the way to +1. Now, just like sine, cosine is a periodic function, meaning that this would continue. The same kind of U-shaped curve would continue forever and ever. So, knowing that, let's find our domain of a cosine function and the range. The domain is what the x values can be. Knowing that this is periodic and continues forever, the x values will never end to the left or to the right. So the domain is negative infinity to positive infinity. The range, however, does have some restrictions. The lowest y value that the graph takes on is -1. The highest is 1, and it includes those endpoints. So it should have brackets when you talk about it in interval notation. The other thing I wanted you to notice is putting the signs of the cosine on the graph, just recognizing these patterns. In quadrant 1, in between pi 0 and pi over 2, notice how the cosine values are positive. In quadrants 2 and 3, the y values are both negative. And then as we enter quadrant 4, 3 pi over 2 to 2 pi, it becomes positive again. So that same pattern that you found down below occurs in the graph as well. And the very last thing I want you to talk about with you is the pattern of the cosine curve that I'll be referencing throughout the week. The cosine curve starts at its topmost point over here. So it starts at the top, then it goes down to 0. So it goes down to the center, then it goes down to the bottom, goes back to the center at 0, and then it ends at the top. So when I reference that the cosine curve has a pattern of top, center, bottom, center, top, I'm referencing that pattern that we see in that U-shaped curve for those key axis angle points. That will come in handy as we start actually graphing sine and cosine curves tomorrow. But the goal of today is just to recognize what the sine and cosine curves look like so that you know conceptually why they have this shape. It is all because of these unit circle values.